All right, let's just jump right into section 10.6. This should be a relatively short and easy video. 10.6 is finding the segment lengths in a circle. If you look at here, look at these chords here, ED and AC. If I was to move ED and create a diameter with that, and I was to move AC and make a diameter with that, what you're going to notice is that the lengths are going to be equal, right? All the radii will be equal. So you got to think that if that's the case, are these chords or these segments of the chords, are they somehow proportional to one another? Well, in fact, they are. If you see here, if you notice, AB is 3, and that's just given to you, and BD is 5. BE is 3, and BC is 5. Rather than setting this up like a proportion like we're so used to doing or we're accustomed to doing, what we'll do instead is we automatically just set it up like this down here. So what you're doing is you're taking each part of the chord, so AB times BC, so each part of the chord, AB times BC, and you're multiplying by it itself, okay? And over here you're doing EB times BD. And the thing that's kind of confusing about that is it's kind of weird just to go ahead and multiply it by itself, so 3 times 5, and 3 times 5. To me, if I'm thinking proportion, I think I'm going to multiply AB times BD and then EB times BC, just because I would multiply one part of one chord times another part of another chord and then get my answer, then work it out. But that's not the case here. We're going to multiply one part of the chord times the other part of the chord, set it equal to one part of the other chord times the second part of the other chord. So, in any case, instead of writing a proportion, we just set it up just like this and just say each part of the chord multiplied by itself and then equals the other side. So essentially here I would have AB, which is 3, times BC, which is 5, is equal to BD, which is 5, times BE, which is 3, and then you'd find out that they're proportional indeed. So 15 is equal to 15. Okay? So here, let's take a look at this example here. So basically what I'm going to do is I'm going to set it up and I'm going to do 4 times 3 is equal to 6 times x. Oh, sorry, let me correct that. The 3 goes with this x. Sorry, the drawing isn't as good as it could have been. So we're going to do 3 times x is equal to 4 times 6. So then you end up with 3x is equal to 24. So x has got to equal 8. Alright, pretty simple. Here's more of a challenging problem. If I'm given a similar diagram, I have 3 on one part of the chord and 6 on the other part of the chord, I should say. How can I find the radius? Now look closely at the picture. Because you might be thinking to yourself, well, there's not enough numbers here. I have to have 3 out of 4 numbers in order to solve for an unknown variable. But do we know this side already? Yeah, from 10.2, I think it is, 10.1 or 2, you should remember that a chord bisects another chord perpendicularly, and it's bisected, so therefore this chord is also 6. So this is 6 and 6. You should know that from the earlier chapter, which some of you guys are having a hard time recalling that stuff, this particular unit. And now you have the x value here. So you're going to set this up. as 6 times 6 is equal to 3x, or 36 is equal to 3x. I want to solve for x. I end up with x is equal to 12. So the x value here is no longer x. This is 12, but that does not help us with, that does help us with finding the radius, because the question, remember, is to find the radius. And neither one of those is the radius. But what do you know about the 3 and 12 chord? Well, first of all, you know 3 and 12 chord's a diameter, so 3 plus 12 is equal to your diameter. So your diameter is now 15. So if your diameter is 15, then obviously you would divide that by 2 to get your radius, and thus your radius is 7.5. If you have any questions, please make sure you ask. Pretty easy, I think, though. Alright, moving on to the last part. If I want to find a segment of a secant, segment of secant, just quickly review what is a secant. Secant is a line that goes through the circle, not a tangent, which is a line that only intersects the circle on one point. This one actually goes through the circle, so 2 points. It's going to have a similar setup. So if you're looking here, let's go ahead and label these parts that are given to us. If you have FG, FG is 7. Then you have IG, which is 6. And JG, which is the entire thing. JG is the whole thing. This is where it differs a little bit from the other one. It's 14. And then GH, the whole thing again, is 12. The way we solve these is we take the whole length times just the external part is equal to the whole length times just the external part. So in this case, I would do the whole length, GH, times the external part, which is just the part outside the circle, which is FG, and set it equal to the whole length, which is equal to GH times FG, which is equal to the whole length of the other segment, JG, times the external part of the other segment, IG. If I set this up again and plug in the numbers that we have 12 times 7 is equal to 14 times 6. And this is 84 equals 84. So you can see how that works out. Okay, let's look at our last example. It's a little bit trickier. On our last example, we have a secant and a tangent. Notice here, though, what am I going to do when I multiply this side? Well, the external part's easy. That's 12. What's the whole? Well, the whole is also 12, right? So essentially, when I have a tangent like this, I'm going to multiply it by itself. So 12 times 12. And that's going to equal the whole of this other side, this actual secant, and the whole of the actual secant is x plus 10. Times the external part. And the external part is only x. So when I work this out, I end up with 144 is equal to x squared plus 10x. Okay, so we're going to need a little more room to solve for this x, because now we're just into an algebra piece. So if I have this problem right here, I'm going to rewrite it just a little bit. If I have this problem here, x squared plus 10x is equal to a 144, what am I going to do now? Yeah, hopefully you notice it's a quadratic. I'm going to have to end up. And so what I'm going to do is I'm going to set this equal to 0. X squared plus 10x minus 144 is equal to 0. And now I'm going to have to figure out factors of negative 144 that add together to equal 0. And just to cut to this chase, it's going to be 18 and negative 8, right? Because negative 18 times 8, I'm sorry, negative 8 times 18 is negative 144. 18 minus 8 is 10. And so then our answer becomes x minus 8 times x plus 18. And that equals 0. Now, this ends up becoming x is equal to 8 and x is equal to negative 18. Now, why is negative 18 not a solution? Well, that's because when I go back in here, if I was to plug negative 18 into the x value, that's going to make the secant a negative length. You cannot have a negative length, so that doesn't work. So that's why our answer is only x equals 8. And that's pretty much it. Again, if you have any questions, please let me know, but you're going to have to brush up on some of the stuff that you learned in the last section, and you're going to have to brush up on some of your factoring mode. Remember, this is all just algebra with geometry kind of setting how to set up the problem. All right? Any questions, let me know.